Welcome to This Explainer. Today, the object of study is an absolutely fascinating one. It's the authoritative TM722 doctoral portfolio presentation by Yuri Jose B. Sesikin, which details the development of a cutting-edge, cloud-based engineering document control system. This system was specifically designed for the University of San Jose Recoletos. To put this into perspective, this digital environment was built to manage every single piece of engineering and commercial documentation for the massive 12-floor quadricentennial campus fit-out works. It is a massive technical undertaking. The architectural journey today covers 5 main areas. First up, the hard copy crisis. Second, a cloud-based solution. Then, project feasibility and value, followed by interface architecture. And finally, a highly detailed look at the high-fidelity screen mockups. Section 1. The hard copy document crisis. Vulnerabilities of the is system. Okay, let's dive into this. When a massive 12-story campus fit-out relies on a completely manual, hard copy-driven workflow, severe operational vulnerabilities are practically guaranteed. Just try contrasting the manual data entry of static Excel logs against dynamic digital environments, and it reveals a dangerous reality of unmonitored deadline blind spots. It's a recipe for costly delays. Critical blueprints just sit unreviewed on desks, literally stalling site work without the system raising any immediate flags. These field risks just keep compounding. You've got severe indexing friction and absolutely zero real-time progress visibility. But here is the most critical vulnerability by far: the huge risk of outdated revisions making their way on site. Without a digital link connecting the master log to the physical construction floors, site workers frequently and mistakenly build from obsolete blueprints. And as you might guess, that causes massive physical rework. Section 2. A cloud-based solution. The proposed-to-be system. To resolve these historical bottlenecks, a cloud-based engineering document control system, or EDCS, is introduced. This is actively defined as a centralized electronic management framework, custom-mapped perfectly to the 12-floor layout. In this proposed architecture, the platform itself actively governs the processes. So, rather than relying on a human document controller for routine administrative steps, the document natively drives the workflow, all on its own. The core automations here are real game changers. They include a digital transmittal portal, automated workflow routing, real-time KPI dashboarding, and immutable version control. What's brilliant is how the system natively enforces contract review timelines. It uses automated routing and alerts without demanding any manual intervention. Ultimately, this transforms the site office into a proactive, data-driven management hub. Moving right along to Section 3, Project Feasibility and Value, Economic Justification. Specific economic metrics establish exactly why this transition absolutely had to be financed by the University Project Management Unit. The data presents highly tangible cost avoidance benefits. Shifting away from manual logs yields 180,000 pesos in labor savings, plus 120,000 peso reduction in administrative supply cuts. Crucially, though, take a look at the projected 450,000 peso material rework reduction. That savings is achieved purely by eliminating the use of obsolete blueprints on the construction floors. Now, to guarantee 100% contractor adoption within a very restrictive 2-week mobilization window, a highly strategic decision was made. Complex enterprise software was bypassed entirely. Instead, a universal web portal ensuring ecosystem compatibility was developed. It's a zero-installation, browser-accessible portal that mandates standardized unencrypted PDFs. This basically removes any software friction right out of the gate. Section 4. Interface Architecture. The architecture of efficiency. Strict user interface principles actively govern the platform, prioritizing content awareness, aesthetics, and minimal user effort. These design rules are absolutely crucial. They ensure smooth navigation and actively eliminate the historical document control black holes that previously paralyzed the fit-out project. Section 5. High-fidelity screen mockups. Technical interface deep dive. This is where the technical brilliance of the custom-tailored interface designs for the USJR 12-floor campus system truly shines. And this brilliantly illustrates the layout consistency grid. It's designed specifically to reduce visual fatigue and accommodate varied computer literacy by breaking the screen into 3 very distinct operational areas. A top navigation area commands exactly 10% of the viewport. The middle work area handles all the core tasks, taking up 80%, and the bottom status area utilizes the final 10% for real-time SLA alerts. It's a highly optimized spatial distribution.
Analyzing the interface structure diagram reveals that the backend architecture strictly adheres to the 3 clicks rule. This means any action initiated from the main dashboard is executed with absolute minimal mouse clicks. It effectively streamlines the entire progression from initial upload validation directly through to the final blueprint auditing console without any unnecessary navigation friction.
Here is Screen 1, which serves as the homepage and executive dashboard. Designed for instant macro submittal throughput visibility, the platform instantly calculates and displays live submittal status distributions without any manual logging. It also features a real-time SLA status tape alongside dynamic vertical floor-level bottlenecks. This functions as a highly proactive warning list for any approaching 7-day deadlines.
Now, what's really interesting about this slide is how Screen 2 functions as the digital transmittal intake and upload form. The interface actively restricts file uploads until mandatory metadata fields, specifically floor level and trade discipline, are fully indexed via drop-down selectors. This natively resolves historical folder chaos at the exact point of ingestion, completely locking down data integrity from step 1. Finally, with the SLA review console automatically generating immutable, latest revision watermarks, the risk of physical rework is entirely neutralized. The Blueprint Viewer's strict version control capabilities are practically airtight. So it leaves a provocative thought. How will this highly automated, scalable EDCS redefine future capital infrastructure developments across all university campuses? It certainly stands not just as a temporary project fix, but as a permanent institutional blueprint for the future.